All right. Okay. So good, solid question. I actually know the solved it. I would have liked to keep this one for the exam, but too late. Um, so it's certainly easy to get down. It's easy to get down to a certain amount of choices. The amplitude is a good challenge, though. So, but let's get down to the easy part of trying to solve. We can easily solve for omega. That's the easy part. So let's first do that. So we know the general form. Since they're all positive cosine functions here, and there's no, I probably should have stated here that the block starts at x equals a at time t equals 0. But since they're all positive cosine functions, that by definition means that it has started there. But that could be another, actually, now that I think about it, in terms of distractors, I could have doubled up some answers if I had given that information where so knowing that at x equals a at time t equals 0 has to be a positive cosine function, maybe I could have added some information, but I digress. So let's keep the standard equation in the case of it starts at x equals a at time 0. This is the general equation for x. And so we can see that the quantity before the time, and it's in inverse seconds. Technically, it's some people argue whether it's radians per second or inverse seconds, because a radian is not really a unit. It is in a ways, but it's a dimensionless quantity. So inverse seconds here is fine because you want the quantity inside the parentheses to be dimensionless. I know that the omega is also equal to 2 pi over t, but by definition, it's also equal to 2 pi f. So that's easy to solve for. So 2 times pi because we're given the frequency. And 2 times pi is 6.28 times 1.2. So this gives us something like this. This gives us a 7.5 inverse seconds, which is the same as a hertz. So I can immediately rule out 3 of the choices. So I can rule out B, I can rule out D, and I can rule out E. So that's sort of like, that's just good exam strategy, not just for my exams, but going forward into your MCAT, stats, GREs, wherever you're going after school. Where maybe you might not know the full solution, but you can certainly improve your odds by making steps. So don't give up just because you can't complete the whole problem. So we can certainly get down from 5 down to 2 choices just by doing a very quick quick calculation, 2 pi f to get omega. Okay. Now the next part, I hadn't solved the problem in a little while, and I was like, oh, this is a good one. I was like, I've only got the mass, got the force. I know the force is linked to the amplitude, but I'm definitely going to have to do some sort of combination of equations and do some algebra for sure here. So what I was thinking in a sense is I can solve for omega, and so that gets the equations that were rattling around in my head, of course, that omega is related to k over m, the root k over m, so it's linked to k and m. We don't have this spring constant, but I do know that it's pulled from the equilibrium position until the spring exerts a force of 1 Newton. So inside this 1 Newton, that's the maximum force. So F max I know is k times a from Hooke's law. So I've got an equation for a. So in a sense, the way I'm processing the cognitive challenge here is going through these sort of variables. We know in a sense, so this is the quantity I'm looking for. I have this, so can I solve in a sense, so k is my unknown. But then over here, I've got k in terms of, I can describe in terms of omega and m. So I have omega and I have m. So that's the golden ticket. That's when it clicks for me. Okay, I gotta solve for k in terms of omega and m, and then solve for a. That's the algebraic steps to get to the right answer. So this would have been definitely a very good, challenging, like free response question. I think now that I see it. So with all that said, let's get omega, k in terms of omega and m. So square both sides here. So we'll bring this over here. So omega squared would be equal to k over m. So k would be equal to omega squared times m. And that would mean that f max would be equal to omega squared times m times a. So that just means that the a is equal to f max over omega squared times m. And now we have everything, all those quantities are given in the question. I haven't solved for them, but I go 1 Newton. The omega is the 7.5 inverse seconds, so S minus 1 all to be squared, times the mass. It's given in the correct units of kilograms, and this should give you the 0.06. So that should give you correct choice is C. Gives us the correct amplitude, and I can then rule out choice A. Any questions?
When do we use the A max equation? Or why is it that we couldn't use like A max equals A omega squared?
I'd have to think about how I would solve for A max. I guess I would F over M. You could use that. That's a little actually easier. Just give you the same answer? Yeah, it's probably easier to do it that way now that I see it. Does everybody understand that? Is that the way you went? Some of you did, some of you didn't. So that's a little. So I wasn't. Yeah, it just didn't pop up in my head, but I'll do it up here. It's a little bit of a mess, but let's see if I can. Alternative. We know that A max is F max over M. And then we know that that's A omega squared. So we can just see that we end up with the same equation. So that A will be equal to F max over omega squared times M. So, yeah, probably easier. Both are fine. Other questions?